We're now going to look into graphing lines. Now, graphing lines will have some slope and we'll have a y-intercept. Those are going to be two really important points when we graph lines. As a reminder, let's do a couple questions on slope. Now, slope, we use the letter m. And remember, that's called change in our y over our change in our x. How do we change in our height while at the same time dividing by changing in our horizontal axis, or our run, as we like to say. So I like rise over run. That to me is the easiest way to remember, though some people say delta y over delta x as well. And we do have a formula for that, ya minus yb all over xa minus xb. You could actually switch those around. It could be, if you wanted, you could have this as yb minus, well, maybe I'll write or. You could have m. Our slope is m. So m equals yb, I'm going to move this after. So yb minus ya all over xb minus xa. So that can also be a way we use this formula. So it doesn't really matter. We will now look at slope and we'll try to figure this out by graphing. So it wants us, what does it say? Find the following slopes of m1, so slope of the one line and the slope of line number 2. So I like to start by choosing the left point. Oh, so this one doesn't have, in the previous chapter we had points that we could easily look at, but that's a point. Ooh, and there's a nice one right there. So we will look at those and we'll take a look at the slope. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, I started at the left point. I always choose that just to be consistent, and I have to rise down. So I'm going to go minus 9, and then I'm going to go to the right. 1, 2, 3. So that's going to be a positive 3 because I'm going towards the right. I'm trying to do that in green, which apparently is not possible. 1, 2, 3, and that's again to the right. So that's positive. 9 over 3, 9 over 3, negative 9, I should say, is negative 3, or negative 3 over 1. Now take a look at line number 2 here. So see here, I'm not going to choose this as a point because that lies, I don't know what that is. Okay, so 1, 2, 3, 4, 5. You go over 5 and up 2.5, so 5, 2.5. That's not really a nice point. I want one that lies perfectly, like right here. That's a good point, because you would go over 4 and up 1. So that's a good point. And is there one over here that's good? Yeah, I mean, any of, like, that's good or that's good. So I'll do the furthest one here. I'll make this the point. Okay, so start at the leftmost left point. So I'm going to go 1, 2, 3, 4. So I'm going to go up 4. So I'll do positive. Then I'll go right, which is also positive. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 to the right, so positive 8. And that can be reduced to 1 over 2. And remember here how I said this. You could also write or. You could have negative 3 over 1 if you wanted. Okay, so that's finding slopes. Let's try B here. So line number 1, we're going to find some nice points. So right there, that crosses right at an intersection. Right here. So I will find the slope of this thing, which is down 2, so minus 2. And to the right, which is positive, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So positive 10, because I'm going right. Now that can reduce to negative 1 over 5. Both of those numbers can be divided by 2. Now I'll need to find, okay, so that's a good point there. And I don't know. I mean, they're all kind of, this one's pretty close, so we'll use that one. I guess it doesn't really matter. We're just trying to get just a reminder of how to do this. 3, 4, 5, 6, 7, 8, 9, 10. So up 10, so plus 10. And to the right, 1, 2, 3, 4, 5. So that will be a plus 5 because we're moving right. Right is always positive. And that can reduce to 2, or 2 over 1. this one here is now asking us to find the slope of a couple lines. We want to find slope 1. I guess this should maybe say AB. So I've just changed it here, slope of AB. And in order to do that, we're going to need the formula. And we need to label this. So this is an X and this is a Y. And, well, so is this. This is an X and a Y. But we got to label them A's. And got to label these B's. So if we're going to find the slope of AB, it would be YA minus YB over XA minus XB, which in this case would be 2 minus 4 over 1 minus 5. And 2 minus 4 is negative 2. 1 minus 5 is negative 4. Both those negatives cancel out to be a positive, and 2 over 4, both of those can be divided by 2 to get 1, to get 2. So your slope is a half. Now, just for the sake of this, let's try the other formula, YB minus YA over XB minus XA. So all I've done is switch it around. Let's take a look. YB is 4 minus YA is 2 over XB is 5 minus X1 is 1. So just notice here that that minus sign is terrible, but notice that the numbers are completely flipped around. 5 minus 1, 1 minus 5. 4 minus 2, 2 minus 4. Now will that make a difference? 4 minus 2 is 2. 5 minus 1 is 4. That reduces to a half. So they're both the same. So it doesn't matter which formula you do. Now, I've grown up to be using to not use this way. I use this one. You can see buried in there. I'll have to move that after. But I'm not used to this YA minus YB. I've always done YB minus YA. But just to be a little more consistent with what we've done before here, we will stick with this. But let's write it the other way here. M equals YB minus YA over XB minus XA. So I found the slope for AB. I also need to find the slope for CD. So M, well, first we can write down this was a half. But for MCD, doesn't really matter which one, but we'll do YA minus YB over XA minus XB. And what are my numbers here? YA, oh, I didn't even write my numbers. Okay, so this is XA and YA. Those are both my A's, even though it says C. I'm going to make them A's. And this would be my XB and my YB. So, YA is negative 2 minus 1. So negative 2 minus YB is 1. XA is 0 minus XB is 6. So negative 2 minus 1 is going to be negative 3 over negative 6, and that reduces to a half as well. But two negatives are a positive, and 3 over 6 can be reduced. Now, it is worth maybe mentioning here that both of these slopes are the same, so we could make a special note here. Note that the line AB, so AB, and the line CD are parallel. It didn't ask us for that. I'm just making a point here to remember that if the slopes are the same, that means that these things are parallel. Okay. Now, it wants us to here, before we leave these examples, take note of the y-intercept. Y-intercept. So the y-intercept I will do here, probably in blue. And the y-intercept, we'll take a look at the y-axis here. Now for line number 1, which you can see right here, it wants to know where is the y-intercept? Where do we intercept the y-axis? Where do we cross the y-axis? Now it looks like we cross around here. In fact, we cross right here. That's where our line crosses the axis. So that happens at 2. Here's 0, then there's 1, then there's 2, then there's 3, then there's 4, then there's 5. So we cross the y-axis at 2. So we say the b value, b is going to be y-intercept. I don't know why, but that is 2. Now look at line number 2. Okay, so here's line number 2. And here I am, I'm going up, and I'm going here. When do I touch the y-axis? Right there. Okay, so what is that number? Looks like I cross at -1, right? Because it's -1, -2, -3, -4. So I cross here at -1. So we say the y-intercept of line number 2 is -1. Let's keep trying here. Okay, so I've got line number 1 here. When do I cross the y-axis? Oh, right there. So how high is this? Well, this is 0, so 1, 2, this is a 3. So we're at a height of 3. So we say the y-intercept of line number 1 is 3. And for line number 2 here, okay, when do I hit the y-axis? There. Okay, so right there, that is our y-intercept. And so there's -1, -2, -3. So my y-intercept is -3. I can not mess this up. So let me just erase these. So I'm going to zoom out here. Just notice that I can't find the y-intercept for this last one because I can't look at the graph. Okay, so we will stop this video and we will do example number 2 in the next one.